Hey guys, this is Mrs. Rooker, and I'm going to be doing day 4 with you guys, which is talking about intercepts, but it's really also kind of reviewing or combining everything we've learned so far this unit. So we'll start with what's in this little box here. We'll start with X-Intercepts. To find the X-Intercepts, blank, the quadratic, and blank. So what an X-intercept is, if you think of a graph, the X-intercept is where the graph, or in our case the parabola, crosses the x-axis. So this is the x-axis. Those points there are the X-intercepts. And the X-intercept are where y is 0. So if we take a problem and we make y equal to 0 and we solve for x, that'll give us the X-intercepts. So that kind of takes us back to last unit. In order to solve, or another word for solve in this case is to find the zeros. To find the zeros, we factor the quadratic and solve. So long story short, all you have to do to find the X-intercepts, or zeros, I'm going to write that those are the same thing, zeros, you factor and solve. Actually, you might hear them called a lot of different things. X-intercepts, zeros, solutions, answers, they all mean you factor and you solve. So that's why we did last unit before we did this unit, because now you all are experts at factoring and solving, and that's how you find X-intercepts. All right, Y-intercept. So Y-intercept is where the graph crosses the y-axis. So point to it over here. This vertical one is the y-axis. And that is, if the quadratic is in standard form, it's really easy to find the y-intercept. So like this, that's in standard form. The y-intercept is your c value. Remember, this is your a, that's the number in front of this term is your b, and the number on the end is your c. So in this case, your y-intercept would be -10. So super easy to find it when it's in standard form. All right, minimum and maximum values. It's always the y value of the vertex. That'll give you your max or min value. So if you look at this graph that I have over here, since it's pointing upward, the vertex is down here. This is a minimum value. Minimum value means where is the graph at its lowest? Well, it's at its lowest at the vertex here. These arrows mean it goes forever up, which means there is no maximum value. So if your parabola is opening up, like this one is, it has a minimum. We just call that min, usually. All right, and then if our parabola is pointing the other direction, it would have a maximum. So if it's pointing down, we have a max, which a lot of students kind of mix those up because they think up, oh, that's going to be a maximum. No, it's kind of opposite of what you would think. All right, and then last thing on here, axis of symmetry, the x value of the vertex. I need to switch up my colors, too much blue here. Gives the line that divides the parabola in half. So your parabolas should always be symmetrical, meaning you could fold them in half and they'd be the same thing on either side. The axis of symmetry is a little dotted line that you can draw right through the vertex. And if you folded the parabola over that line, you should get the same thing on both sides. Obviously, my parabolas aren't perfect. So this is the axis of symmetry here. And you can always find that by the x coordinate of the vertex. All right, so that's a lot of information, which is why you take notes, so you can refer back to that and eventually memorize this information. I don't expect you to have it all memorized right away, which is why we take notes and look back. All right, so we are going to find a bunch of things, all these things for this first problem. So we'll start with vertex. Unfortunately, this right here is in standard form and not vertex form like we like. So we are going to have to find the vertex using the formula x equals negative b over 2a. That's the formula for finding the x-coordinate of the vertex. So x is going to be negative b is the number in front of the x, and we're going to make it negative or opposite of what it was. So positive 1 is going to become negative 1 over 2 times a, which in this case is going to be 2, which if we reduce that, we get negative 1/4. So that's the x-coordinate of the vertex. Most of the time, or well, not most of the time, but a lot of the time you'll get a nice whole number for x. That's kind of a mean x value to give you, because we now have to use that 1/4 and plug it in to find the y value. So we plug into this equation, so it's going to be 2 times 1/4 squared plus negative 1/4 on both of those, whoops, minus 10. All right, we always start with the exponent. Remember PEMDAS, you start with the exponent here. So 1/4 squared, when we square this, we just square the top and square the bottom. But remember, a negative times a negative is a positive. So 1 squared is 1 over 4 squared is 16. We're multiplying that by 2, adding negative 1/4, and subtracting 10. Holy cow, this is a painful problem. Keep going. I need to find some other room to do my work. I'll do it over on this other side. So 2 times 16 is going to be 2/16. I'm going to reduce that so that we don't waste too much time. 2/16 reduces to 1/8. Plus negative 1/4, so that'll be minus 1/4, and then minus 10. 1/8 and 1/4, I need a common denominator, so I'm going to multiply this second one by 2 on top and bottom so that I can get a common denominator. So I'll have 1/8 minus 2/8 will be negative 1/8 minus 10 gives us negative 10 and 1/8. So I warned you, that was a pretty ugly vertex. Yours will not normally be that bad. Is the rest of this, now that I know what my vertex is going to be a lot easier. So I'm going to erase some of this work so that we've got some room to find the axis of symmetry. I'm going to sketch what this looks like. We have a parabola. It's positive in front. Our a value is positive, which means it's pointing upward. It's got a vertex of negative 1/4, negative 10 and 1/8. So this is just a really rough sketch, but it's going to look something like this. It's pointing upward. Looks like that. The axis of symmetry, remember we wrote it up here, is the x-coordinate of the vertex, and we always write it as x equals. We can actually draw the axis of symmetry in here. It's always a dotted line. All right, max and min. Since this parabola is pointing upward, this is down here at the vertex is the lowest possible point on the graph. It goes up forever, so there's no maximum, but there is a minimum. So we're going to circle minimum, and the minimum is always the y value of the vertex. That's what it said right up here. So the y value of the vertex is negative 10 and 1/8. All right. Now, domain and range is something we can easily find. So domain is how far left and right the graph goes. So this arrow means it goes forever to the left. This arrow means it goes forever to the right. So that's all real numbers, or A, R, N. Some people use this all real number symbol. You can use either one. All right, and then the range. How high up does it go and how low does it go? So it goes up forever, but it never goes below this minimum, negative 10 and 1/8. So that's the lowest point. So y is always greater than or equal to negative 10 and 1/8. All right, almost done with this problem. Y-intercept. Look back to our little box up here. Y-intercept can be found, if it's in standard form, which it was, by just looking at what your C value is. This right here was our C value. Oops, I should have circled the negative. Negative 10 is your y-intercept. Which is actually really good to write that as a coordinate. So that's the coordinate point 0, comma, negative 10. The y value is negative 10. The x will always be 0 on a y-intercept. All right, last thing we need to do is find the x-intercepts. So x-intercepts can be found, if we look in our little vocab box, by factoring and solving. So we're going to factor this. Let me erase so we can actually see. That's a hard trinomial, which means we have to do big X and factor by grouping. So let's just start with 2x squared plus x minus 10 multiply a times c, you get negative 20, that goes at the top, and then b goes at the bottom. Then go your factors of 20, 1 and 20, 2 and 10, 3 doesn't go in, 4 goes in, 4 times 5, 5 goes in, but we already have it, so we're done. Since we're trying to multiply to a negative, we would know 1 is negative and 1 is positive, which means we really want the difference to be 1. So this one has a difference of 1. It's going to be 5 and 4, or 4 and 5. Order doesn't matter. And then we have to decide which one's negative. The smaller one will be negative in order to still combine and give us a positive one. All right, since it was a hard trinomial, we are going to rewrite it, 2x squared, except the middle term gets split into positive 5x minus 4x minus 10. And then because it's got 4 terms, we split it down the middle and do factor by grouping. If I look at these first two, the only thing they have in common is an x, so we factor out an x. When we divide both terms by x, we're left with 2x plus 5, which I copy over here. And I factor out a negative 2 to get from this what I have here to here. So my factors are going to be the thing that I have 2 of. That becomes one of the factors. And then the leftovers are my other factor. And then, because we are supposed to solve, we need to set each factor separately equal to 0. So 2x plus 5 equals 0. Subtract 5. 2x equals negative 5. And then divide by 2. X equals negative 5 halves. And then the other one's easier. X minus 2 equals 0. Add 2 to both sides. X equals 2. So we have 2 x-intercepts, which should hopefully make sense because we have an x-intercept here, and it also crosses the x-axis here. So this one must be our negative 5 halves, comma 0. We always want to write it as a coordinate point. So negative 5 halves, comma 0. And then this must be the point 2, comma 0. So those are our 2 x-intercepts. Negative 5 halves, comma 0, and 2, comma 0. All right, so that one was a little bit painful, but I promise you the next one will be easier. We'll get nicer, prettier numbers, and hopefully it'll make a lot more sense when we have those nicer, prettier numbers. So if you want, this might be a good idea or a good time to kind of pause the video and see which of these things you can figure out on your own. And which ones you need to watch the video and pay more attention to. All right, so Vertex, since this is in standard form, we are going to do x equals negative b over 2a to find the x coordinate of the vertex. So negative b, this is our b value, so that's just going to be negative 2 over 2 times a, which is 1. So that's going to be negative 2 over 2 times 1 is 2. Negative 2 divided by 2 gives us negative 1. Already you can probably tell much nicer numbers than we had to deal with last time. All right, now to find the y coordinate of the vertex, you just plug into this original equation. Y equals, but we're going to plug -1 in for x. So, whoops, -1 squared plus 2 times -1 minus 63. -1 squared is +1. 2 times -1 is -2, and then we still have this minus 63 on the end. 1 minus 2 is -1, minus 63 is going to be -64, which is kind of a big negative number, but at least we didn't have to deal with a bunch of decimals and fractions there. All right, so again, this is going to be a parabola that's opening upward because it's positive in the front, and it's got a vertex of -1, -64. So it's, I don't know, somewhere over here. That was a pretty ugly parabola, but you get the idea, just a rough sketch. The axis of symmetry is the little dotted line that goes through the vertex, and it's always going to be the x coordinate of the vertex. So that's just -1. Max and min, since this is pointing upward, it has a lowest possible point. So we call that a min, and it's always the y coordinate of the vertex. That means the lowest possible point on that parabola is down at -64. Domain for all parabolas should be all real numbers because they all go forever left. Whoops. Or forever right. That's supposed to be the all real number symbol, but I made it kind of ugly. There you go. All real numbers. All right, range is how high up and down it goes. If it's pointing upward, your range is going to be y is greater than or equal to something. And it's always the y coordinate of the vertex, so -64. And then finally, Y-intercept, or I guess not finally, we have X-intercepts after that. But Y-intercept, if you remember from the notes up there, Y-intercept is the C value. So if we go back here, that's our C, -64. Or sorry, -63. Which we should actually write as a coordinate point. That would be the point 0, 63. -63. So y-intercepts are always 0, number. X-intercepts are number, 0. All right. So lastly, we need to find the x-intercepts, which means we need to factor. So I'm going to erase so I have some room to do all this. So we're factoring and solving x squared plus 2x minus 63 equals 0. Now, I love that this is an easy trinomial. It'll save us some time. So -63 at the top, 2 at the bottom. What multiplies to give us 63? 1 and 63. 2 doesn't go in. 3 does go in. That's going to be 63 divided by 3 is 21. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. 7 goes in. That's going to be 7 times 9. 8 doesn't go in. 9 goes in, but I already have 9. So that's my completed list. Since we're multiplying to a negative number, one's going to be positive and one's going to be negative. 7 and 9 will subtract to give us 2. So it's going to be 7 and 9. The smaller one will be negative in order to still multiply to a positive. Or sorry, to combine and add to a positive. So since it was an easy trinomial, I get to go straight to the parentheses. X minus 7, x plus 9. Set each factor equal to 0. X will equal 7 and -9, which means our x-intercepts will be, we always write these as coordinates, 7, 0, and -9, 0. which hopefully makes sense because based on my picture, this looks like it could be about 7. That looks like it could be about -9. Well, I mean, it's a really bad sketch, but you get the idea, hopefully. All right, we got to bust through a couple of these. I think what I'm going to have you do is pause the video, try this one on your own, and then I'll put all the answers up in just a minute. Guys, here are the answers. The vertex was a little bit ugly with some decimals, but remember, axis of symmetry is just the x-coordinate of your vertex. And then the min or max is always the y-coordinate of your vertex. The y-intercept is always the c value when it's in standard form. And to find the x-intercepts, we factor. All right, a woodland jumping mouse hops along a parabolic path, which that just means it's a parabola, a U shape, given by the equation, highlight that equation, where x is the mouse's horizontal distance in feet and y is the corresponding height in feet. Can the mouse jump over a fence that is 3 feet tall? We need to know the height that the mouse can jump because we want to know if it can jump over 3 feet high. So to find the height, we need to know what the vertex is. We know this parabola is opening downward, which hopefully makes sense because that's how the mouse is going to jump. It's going to be kind of that shape. But we don't know what the height is yet. So we need to find that. So to find the x-coordinate of the vertex, we do -b over 2a, which is going to be, this is our b value, so -4 over 2 times a is -2. That'll be -4 over -4, which simplifies to just 1. So the x-coordinate of the vertex is 1. But x is the horizontal distance, that's not the height. We need the y value, which is the height. So we're going to take the equation, we're going to plug back into the original equation, but we're putting 1 in for x. And that will tell us the height. So we always start with squaring. 1 squared is 1. -2 times 1 is -2. And then 4 times 1 is 4. -2 plus 4 is 2. So y equals 2. Meaning the height of this parabola, or the maximum height, is going to be 1, 2. Our parabola is going to look something like that. So max height equals 2, which means no. He cannot jump 3 feet high. Try to bust through these next 2 graphs. So this one is really awesome because it's in vertex form. Vertex form is gives us the vertex here and whatever number is being added on the end. If there's no number being added on the end, we just put 0. And we always do opposite of this number. So opposite of 3 is -3, comma, same as this number. So -3, 0 is going to be our vertex. So we draw that point. And then I always go over, if it's positive in front, I go over 1 up 1, because 1 squared is 1. Then back to the vertex, over 2 up 4, because 2 squared is 4. And then over 3 up 9, because 3 squared is 9. Some teachers do the 1, 3, 5 method, where you don't go back to the vertex. Okay, all right. Axis of symmetry is always going to be the x-coordinate of the vertex. Let's graph that. Domain. All real numbers, always for parabolas. Range is y is greater than or equal to, since it's pointing up, it's greater than or equal to 0, because that's your y coordinate of your vertex. Since this is pointing upward, it has a lowest possible point. That vertex is down low there, so that's a min. And the minimum is your y value of your vertex, which is 0. The y-intercept. I couldn't tell based on this equation, because it wasn't in standard form. If it was in standard form, it'd be our c value. But I can tell based on my graph that the y-intercept was up here at 9. So sometimes you can just tell things by graphing it. Also, if you look at the graph, we can see where the x-intercepts are. Or, well, in this case, we only have one x-intercept, which can also be called a double root, but you'll learn more about that later. So the x-intercept, we can see here, it touches the x-axis at 3, 0. So that one was a nice one. It was quick because it was in vertex form. All right, and then the last one, again, we'll bust through it. This is in standard form, but there's no c value. It's like a 0 on the end. So to find the vertex, we do negative b over 2a. Oops, x equals negative 6 over 2 times negative 3. That'll be negative 6 over negative 6, which reduces to 1. And then we plug 1 into the equation to find the y value of the vertex. All right, we always square first. 1 squared is 1 times negative 3 is negative 3 plus 6. Negative 3 plus 6 is 3. So my vertex is 1, 3. And then I noticed that this one's pointing downward, and it's got an a value of negative 3. So it's pointing downward because it's negative. That means instead of going over 1, up 1 like I would normally, I go over 1, down 3. The amount we go up or down, which, well, it's now down, is tripled because of the fact that there's a 3 in front. So over 1, down 3. Whoops. And then I would normally go over 2, up 4, but I'm instead going to go over 2, down 4 times 3 because I'm going 3 times as much. So I'm going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in both directions. I don't want this video to go on forever, so I'm not going to be able to explain that in real big detail, but if you have questions on that, please ask your teacher in class. All right, axis of symmetry is always the x coordinate of the vertex, so x equals 1. Max or min is always the y coordinate of our vertex. And in this case, since this parabola is opening downward, it has no minimum because these arrows mean it goes forever down. But this vertex is its maximum, so it's a max at 3. All right, the y-intercepts, my drawing's not very good, but the y-intercept should be the c value, which, remember, there was no c value, so we called it 0. The y-intercept is 0, and you can see that it actually, crosses the y-axis here at 0. And then the x-intercepts are also going to be 0 because it crosses the x-axis at 0, and then it looks like also at 2. So we could just tell that based on the picture. And then the domain, all real numbers, and the range is y is less than or equal to, because it's pointing downward, less than or equal to 3. If you couldn't tell based on the picture what the intercepts were, the x-intercepts, remember you could have factored this. Since there's 2 terms, we would have factored out a GCF and then set each factor equal to 0. All right, thank you guys for following along. I know that was a really long video. There's a lot of information here. So make sure to come to class with questions for your teacher. All right, thank you guys. Have a good one.